The topic for today is debris flow modeling. You are using GIS and remote sensing, as you can see in the screen, for disaster risk mitigation activities. I think this is one of the core topics and core field that we are working upon, and you will see like how this topic is important to our society as a whole. I'll just give you a brief agenda about this presentation. This webinar will be including, I am assuming that everybody has a background of remote sensing and GIS, so I'll not be going into the depth, but yes, I'll be covering the major important topics to give you a brief idea about remote sensing and GIS technologies, so that in later on topics you will be easily understanding like how we are utilizing these techniques in disaster monitoring and activities. So we will be covering what is remote sensing, what is GIS, what are the applications that are related to GIS technologies, and specifically in the disaster management, how GIS is playing a critical role. Then, though GIS has various applications, but today we will be dealing in detail about debris flow and its type, and I will be telling you what are debris flow and what are its type and how to monitor the disaster. Then flow modeling is a technique that we will be using to delineate or to model the debris flow. So this will be an important section of this whole presentation. So moving on, we have also the content related to the tools. So this will be a very important presentation to the students who are going to enter industry. So who have a perspective to enter job market or in private or public or government sector or any industry. So in industry, what type of tool, what type of commercial or open source tool that we are utilizing, how we are integrating our knowledge to the application part, how we are dealing with all those scenarios in a real time. So that I am going to give you a brief idea about it, so that if you are entering any industry related to remote sensing and GIS, it becomes easier for you to understand and to do all those things which are very much necessary in this field. We will be also working about the flow model, what are the input, what are the boundary conditions, and what are the related outputs for this flow modeling. So, and the last, we will be dealing with its application part. So like how debris flow modeling will be important as in a society as a whole, in risk mitigation activities, in respond and discovery activities, and so on. This is a brief idea that I wanted to give you before entering into the presentation. First, we would like to, as I have told you, I would like to give you a brief idea about remote sensing. What is basically remote sensing? So you all might be knowing, as you all are attending this webinar, so you must be aware of the remote sensing and GIS techniques. So just to give you a brief idea, remote sensing is the science of analyzing data without physically interacting with the object. So this is a very basic principle of the remote sensing, and it is also a process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance. So this is basically a phenomena of detecting and monitoring the characteristics that an object has on the ground. For example, we have special cameras that collect remotely sensed images. So cameras just take images, and what we as a researchers, what we do, we sense those things about the earth. So remote is, obviously everybody might be knowing what is remote, so we frequently use the term remote location or something like that. So remote location means what? Location that is far away from our reach, or that is very much not in connected with the area that we are associated with, so that area is called remote area. So from that terminology, the remote word has come into the picture. So now sensing means what? We are sensing those things by sitting at our workplace, and we are analyzing and interpreting things that are far away from our reach. So we have cameras on the satellite and airplane. The images of large areas of the earth's surface are being captured by the cameras and sensors, and allowing us to see much more than standing on the ground. So for example, you people are sitting, I'm giving the presentation. So what I can see my room. My eyes will not see beyond the room. So what about the things that I cannot see? It's not like that, that things are not important. Those things play a very important role. So in order to analyze the things that we probably are not able to see or not able to reach, in that thing, cameras and sensors come into play. So, for example, I'll give you some 2, 3 examples more so that it gives you a much more clear view about the remote sensing technology. We have a sonar system, for example, on ships that is used to create images of the ocean floor. For example, now we cannot go till the ocean floor. So for that, sonar system is there, which gives us a picture before at the depth of the ocean also. And what we do, we just take those imagery, we sense it, we do analysis, we do interpretations, and so on. So like that, we have cameras and sensors for temperature detection, for agricultural fields, and so on. So like this, we take all those imageries through remote sensing technique and we analyze it. So this is the whole process of remote sensing technology. This is sunlight, atmosphere, earth features. We have then satellite, antenna receiver, and computer analysis. So we can see, like you can type in the chat box like what are the 2 kinds of remote sensing techniques that we are going through nowadays. So how many types of remote sensing techniques are there? You can type in chat box, and I can see later on like you have an idea or not. So now I'll just give you an idea like how many techniques are there. Remote sensing techniques, we have 2 types of remote sensing techniques, that is active and passive. So this is the slide that is shown. This shows a passive remote sensing technique. Why? Because the sun is the source of illumination. So we have a sunlight, we have atmosphere. So sunlight is interacting with the atmosphere. Then it is coming to the earth's surface, and then it is getting reflected back to the satellite or the cameras that is mounted on the earth's surface. Then we have an antenna receiver, and then it is going to the computer analysis where we are sitting, or you people are sitting. So this is the whole process and whole phenomena of passive remote sensing, where sun is the source of illumination. Now we also have an active remote sensing type of technology, where sun is not the only source of illumination, but we have radar or some sort of a sensors that creates its own energy. So they create their own energy, they transmit towards earth's surface. The rest of the phenomenon remains same, interacting with the atmosphere, going towards the satellite, then antenna receiver, then the computer analysis. So in this active remote sensing, what we have a very small bandwidth, since we have a sensor and radar which has its own wavelength and its own bandwidth and wavelength. But in case of sun, that is having its own illumination, and you can see the wavelength, the bandwidth that sun is covering, it's huge. It is covering the huge amount of land or any activities. So the bandwidth we have for passive remote sensing is much higher. So in passive remote sensing, we have visible band, we have NIR, phasor, and shortwave infrared, and so on. In case of active remote sensing, we have radar and lidar in this scenario, and so it takes into the microwave region of the wavelength. It detects its energy and illuminates in that particular microwave region. So I should say that it measured the backscatter of the image or sensor, and produces it gives those backscattering. It measures the distance between the rays that are reflected, and then how much the amount of rays is backscattered. So it measures the distance and it gives antenna, and then it is given for the further processes. So these are the two types of remote sensing technologies that we are dealing with. So I hope this remote sensing part is clear what we are doing. So we are dealing with these technologies. It has two types of scenarios capturing the Earth surface, and we are dealing with both active and passive remote sensing technologies. So moving on, now, what is GIS? So GIS is basically a geographical information system. So that creates, manages, analyzes, and maps of all type of data. So GIS has become a core field nowadays, and if you will see a decade before, people were not aware of this field, but now GIS is getting implementation in each and every field, whether it is IT or it is automobile or it is automation technologies. In each and every field, this technologies is getting renowned. So because why? Mainly it helps user to understand the type of data that we are working about, and it helps in the real world scenarios, whether you are taking a map, Google Maps you are using, in that also GIS is being used, or you are monitoring any activity, whether it be agricultural, disaster, forest, urban settlements, and so on. Everywhere nowadays GIS is getting utilized. So I should say that it is a foundation of any image analysis and the interpretation and manipulations. So GIS mainly integrates the five components. So the major five components of GIS are hardware, software, data, people, and methods. So in hardware, what you do? In hardware, we have a computer system or we have a laptop. The memory, the RAM, all those things come in the hardware. Now, software. So we have different types of softwares that we are dealing with GIS. For example, we have GIS software, ArcGIS or QGIS, or now GIS is also embedded in the image processing software, that is AirDAS, and so on. So obviously you people must be working in these kind of common softwares that are related to GIS. Now we have data. So what kind of data that we use? So we have different types of data in terms of optical data, in terms of microwave data. So optical works in the three zones that, or we can say in a multispectral band when we talk about visible band. So optical comes into picture. We have natural color composite, we have false color composite, and so on. And next we have a microwave data that is there for the microwave region, and we are using a microwave data also nowadays for various other applications. For example, the main application of microwave data is your flood mapping. So in flood mapping and disaster activities, microwave data is of a much more importance. Now, people. People means the industries that are associated with these GIS technologies. So industries in the sense you, me, and everybody, those who are currently associated with some or the other industries. So we have, again, we have agriculture, and we have sprawn mapping or urban mapping and so on. So all these industries that are associated with these type of technologies, that comes under people. Now next is methods. So what kind of methods that you or everybody will be working in this domain will be, for example, a method called segmentation, or image analysis, or we have hazard zonation, geospatial mapping. So these are the methods that come under this GIS domain, which you can utilize it while doing all those kind of manipulations and interpretations. So this is also the clear picture actually what GIS is doing. So GIS is associated, as I have told you, with softwares, with imagery analysis, satellites, drones, classifications, and most important, careers. If I will say satellites, so obviously satellites are taking pictures, cameras and sensors are mounted, then we are doing analysis, whether it's 2D mapping or 3D mapping. Then we have an imagery associated with it, where we are mapping all those things related to the different applications. So as you can see here, some urban areas or vegetation. So we can say like or it depends on the type of applications that we are associated with. So we have software, as I have already told you, the different types of softwares. It can be ARDAS, it can be ArcGIS, QGIS, Snap, Starscape, whatever that we are using. Now careers, GIS has as I have told you from the last decade, GIS has got a wide name out of it. So in from the career point of view also, we can try multiple industries nowadays, and people are welcoming GIS and remote sensing analyst with open handed, what I feel, current to previous situations. Next is classification. So for example, we have an image and we want to classify it on the basis of vegetation, or on the basis of urban areas, or on the basis of natural natural rivers or lakes or water bodies and so on. So in this, you can classify your image based on the classes that you intend to do. Nowadays, now drones have come into picture. It helps in taking and capturing high resolution imageries. So instead of putting expensive satellites and sensors, so drone uh, is a very good option nowadays to capture picture at our utilization, or where we want to utilize our application area, there we can keep drones, and it can easily map, or it can easily sense the areas, and it can give us the pictures for us to analyze it. So as I have told you, like GIS is connected with five things. Now we have multiple things, as you can see in the picture, that GIS is associated with. So on the whole, I will say GIS, it creates, stores, edit spatial and non-spatial data. This is a very important terminologies. I hope the important terminologies that I am taking, you must be writing down. So at least you should note down the important points that I am telling. Maybe it's not in the presentation, but while speaking, I am taking the names of those important terminologies which you will be requiring when you will be entering any industry, or if you are working in industries, then also. So, what is spatial and non-spatial data? Spatial data, obviously, you people, some of the students must be aware of the spatial and non-spatial data. So, spatial data is where we have a location. When we talk about shape, we talk about size, when we have a coordinates, so that is a spatial data that has spatial coordinates in it. But when we have a non-spatial data, it is more or less associated with the attributes of the vector or raster shapefile. So in vector, as you know, we have a point, line, polygon. In raster, we have an imageries. So in vector data, the attributes that are there, so that is called the non-spatial data. That actually defines the characteristics of any object. So what it does, spatial and non-spatial data, it analyzes them and prepare them as a map. So spatial plus non-spatial, what it becomes? Spatial plus non-spatial, it becomes your geospatial. So this is also an important thing. So what is geospatial? It is a mix, or it is the interconnection of spatial and non-spatial data. So we have data collection techniques, analysis, we have reporting. So all those things, when they are interconnected, it comes under the disciplines of GIS. So this was a brief idea about remote sensing and GIS. So now coming to our main part, that is the applications of GIS. So we have various applications of GIS. For example, mapping forest fire. So how will you map forest fire using GIS? So I'll just give you a brief idea so that you will have an understanding of mapping GIS in forest fire. For forest fire, for example, the forest is there, and the fire, see, it can be a natural fire, and generally 90% of the fires that occur is a human made fires, due to the activities that human beings perform, and it has a very negative impact on the environment. So we should have some meteorological data to determine the wind velocity and wind direction, because the fire and the direction the fire will move, it basically depends on the wind direction and wind velocity. So we need that data from the meteorological department. For example, we have IMD in India, so we can take the data from them. Then we have a vegetation coverage to determine the index of flammability, how much flammable the fire is, and then we have to put on some sampling techniques. Then we have topographic data. We have slope and aspect. You can take out all those things from your DEM. It can be of any resolution. Then we need to see the fire starting point, where the fire is starting, and then we will measure the temperature associated with it, and according, when we will interpret all those input parameters, and then we can have some methodology or algorithms put into the softwares, then we can get the output that is related to the forest fires. So this is how you can map a forest fire if you are in a forestry domain. And now moving on to disaster management. This disaster management, since it is basically we are focusing on disaster management only, so I'll deal with this in later on slides. And then we have crop monitoring. So crop monitoring is also one of the major techniques where GIS is getting utilized. In GIS, what we do is we see the crop production, so how much the crop is being produced, and what are the conditions of the crop. So through this GIS techniques, we can find out the acreage conditions and crop estimations. We can do inventory mapping, we can do management, we can take soil, then again topographic conditions, NDVI, LULC, drainage or principal component analysis. We can integrate all those parameters in the GIS environment, and we can see how the GIS is helpful in crop mapping. Now, this next comes geosciences. Geosciences is the industry that I am currently associated with. So, geodynamics and geohazards come under this geosciences. In geosciences, we also have mineral exploration, finding out what kind of a rock sample or a mineral is there in some of the places, or in any place that you might be interested in, to know the rock type or to know the type of minerals that is associated. Then we have this climate studies. We have aerosols detection in the atmosphere. We have been monitoring the carbon content in the atmosphere. So all these things comes under the climate studies. Now we have water body extraction studies. So this is also a very peculiar topic for GIS integration. What we are doing in water body extraction, we are taking any optical or microwave imagery. We are taking out NDWI, that is normalized differential water index. So we'll take out this water index, and then, as you know, like any indices is between -1 to +1. So above zero point 0.2 or 0.3, we will segment our data, and then we can see what are the water bodies. So if you will categorize your data above 0.2 or 0.3 threshold, then you can clearly see your water bodies in the map. Then you can export that data into any shape file or polygon, and you can easily identify and you can easily extract those water bodies. Then we have some land use changes. So land cover mapping we have. So what we are doing in this particular application, we are doing classification, like supervised classification or unsupervised classification. And we are monitoring the changes, like 5 years back there were no buildings, but after 5 years, if you will see, urbanization increases. So in order to monitor those urbanization changes, we have this land cover changes. Urban development also comes under the category of LULC, land use land cover changes. So now coming to GIS in disaster management. So disaster management is one of the main application that today we will be dealing with in the field of remote sensing and GIS. So as you all know that Asian countries that due to its geographical and topographical location are more prone to disasters, and India is one among them.